first of all, let's discuss the difference between the non-blocking assignments and the blocking assignments. So first of all, let's just consider what are the blocking assignments and what are the non-blocking assignments. So first, in terms of the representation, we can just consider that the blocking assignments can be represented with reference with the equals to symbol, and the non-blocking assignments can be represented with less than or equals to symbol. So what is the basic difference between the blocking? The name itself says that the blocking and the non-blocking means if there are two statements, statement 1 and the statement 2, if we are using the blocking assignments until the first statement completes, the execution will not be moved to the second statement. So that is it blocks the execution to the next statement. Those are the blocking assignments. But the non-blocking assignments will not be like that. It means without completing the first statement only, it moves on to the second statement. In order to understand the best difference between the blocking assignments and the non-blocking assignments, we need to just discuss the Verilog stratified event queue. So in that particular stratified event queue, we will be just considering there will be 4 different things. The first will be the active region. The second will be the inactive region. The third will be the non-blocking assignment region. And the fourth will be the monitor. Monitor or means there are several names. One name which and this will be from the earlier time slot, and this will be moved on to the next time slot. Here, let us consider the statement contains 2 things. One is the LHS and one is the RHS. So first, let me consider the blocking assignment LHS equals to RHS. This blocking assignment statement will be continued. This blocking assignment statement, the execution of this LHS and the RHS will be assigned in the active region only. But when it comes, whenever I'm considering LHS, means the non-blocking assignment RHS. So here what will happen is, so this part of the RHS will be assigned, or the value, whatever the earlier value of the RHS is there, will be assigned to that in the active region. But this value of the RHS will be assigned to the LHS inside the non-blocking assignment region. Means once it enters the non-blocking assignment region. So this is the basic difference. And one more difference is with reference with the synthesis. So in the non-block, one more difference is basically the blocking assignments are mostly used in the combinational logic blocks. But in the non-blocking assignment is majorly used in the sequential logic blocks. And when we compare with reference to the synthesis also, there will be a larger difference between the blocking assignments and the non-blocking assignments. For suppose to understand this in a clear fashion, let me consider 1 minute. So to understand this the difference between the blocking assignment and the non-blocking assignment with reference with the synthesis, let me take a small statement, something like always at the rate of passage clock. Begin and end will be there. Let me consider first, I'm assigning the value of the B to A, and later I'm assigning the value of the B to C. Later I'm assigning the value of C to D. So in this particular program, what will happen whenever there is a passage clock, edge of the clock has been detected, then immediately the execution inside this always block starts. So here what happens is the value of the B of the A which is there will be assigned to the B. As it is a blocking assignment, until this particular assignment occurs, it will not go to the next statement. So now what will be the value inside the B here? The value inside the B will be whatever the value which is there inside the A will be present at the end of this statement. Now at the end of the next statement, the value of the B is nothing but A here. So what will be the value there inside the C? Whatever the value which is there inside the A, that will be assigned to the C. Now, what is the value inside the C here? It is nothing but the A. So what is the value with reference to the D? It is nothing but the A. So if you can just consider with these three statements, the synthesis tool will just represent this particular three statements as this one will be the clock signal, and this will be the A, and the final output will be the D. This is what the synthesis tool will be considering this one as. Now, but in the blocking assignment, the major problem occurs when we are changing the, whenever we are trying to change the order of this particular statement. For suppose, let me consider the first order is D equals to C, the second order is C equals to B, and the next order is B equals to A. So here we haven't defined the value of the C yet. So even though whenever we are trying to assign, what will the synthesis tool consider is, the synthesis tool would consider the three flip-flops which are connected in the series. So first it will be considering the three flip-flops. So first it will be connecting the D with the C. Later it will be connecting the C with the B. Later it will be connecting the A with the B. So we can just see that the same code, when the values are being just interchanged, there is a problem, there is a major of the problem which is being occurring here. But this will not be in the case of the non-blocking assignments. In the non-blocking assignments, in whatever the order we are going to take it, it will be assigning the same, the synthesis tool will assign the same amount of the flip-flops. So this is the major difference between the blocking and the non-blocking. So why are we going to prefer the non-blocking assignments in the sequential procedures is, in the sequential procedures, for suppose there is a chance that there are two always blocks which are, there are two always blocks. So we don't know at what time each always block is going to occur. If a variable is dependent, which is there in the first always block is also there in the second always block, if we are using the blocking assignment, there is a chance of some don't care value because of the blocking assignment. So that is the reason why we are going to prefer in this non-blocking assignments inside the sequential procedures. So
just continue.
Yeah. So this is with reference with the blocking and the non-blocking procedures. So a second. So can I go for the next one, sir?
Yeah, anyone have any doubt, you can ask. We can go to the next one, bro.
Okay. So next, so let us try to swap. Yeah, this will also be a very good application of the blocking and the non-blocking assignments. So first, let me consider there are three variables. There are two variables, A and B. What I want to do is I want to have the values of the A inside B, and I want to have the values of B inside the A. So if we want to swap like this, basically with the non-blocking, with the blocking assignments, what is the problem with us? We means immediately the execution should get completed, means at the same time. So what we need to do is we need to take a third variable. Let me consider a temporary variable. Whatever the value of the B, I'm going to store them inside the temporary variable. And in the next statement, whatever the value of the A, I'm going to store them inside the B. And in the next statement, whatever the value of the temporary variable which I have stored earlier, we are going to store it inside the A. So here we can just observe there is a requirement of the three statements to swap the two values, the variables inside, sorry, the values inside the two registers, the reg variables. But when it comes to the non-blocking assignments, as we have already considered, first the RHS will be considered in the active region and the LHS will be evaluated in the LHS region. So therefore, what will it happen is, instead of taking all the two statements, we can directly take something like A non-blocking assignment to B and the B non-blocking assignment to A. So what will happen is, if we consider the actual thing, let me consider here always at the rate of passage clock, and let me consider the begin and the end statements. Whenever a passage clock is being occurred, what will happen? Whenever the non-blocking assignment is being occurred in the active region only, whatever the value of the B is there, it will be retained here. And whatever the value of the A is there, it will be retained here in the same active region, because there is no delay here. because both are working in the same time slot. So in the next time means whenever from it comes from the active to the non-blocking assignment, then whatever the value in the RHS is being assigned to the LHS. So whatever the value of the B is there, that will be assigned to A, and whatever the value of the A is there, that will be assigned to the B. So this is how very simply with the help of the non-blocking assignments, we can directly swap the two variables. So can I continue with the next one?
Yes, you can continue.
So the next one is nothing but the difference between the function and the task. So the major difference first where it lies is the functions and the task. So first of all, the common thing between these two is, sorry for this, the mouse is not working perfect today. The major difference between the major common thing between both of them is they are called as a subroutines. They are called as the subroutines. So what are the subroutines? For suppose there is a very big piece of a code where we want to run that particular code for more than 100 or 200 times. So every time we can't directly, means in a different fashion, means the inputs may vary, something like that. So it's every time it's very tough for us to write the same code or copy paste the same code. Instead, if we can just call a function as in the similar case of a C, directly we can give some values, whatever the values which we require, and directly we can just obtain the values. But in Verilog, whenever we are defining the subroutines, there will be a couple of challenges for us. So in order to overcome the challenges, we have divided the subroutines into two types. One are nothing but the functions and the second are nothing but the tasks. So the major difference between the function and the task is whatever the function is there, we cannot use any timing variables. Inside the function, we cannot use any timing variables. So whatever the time variables are there, we cannot use them. But inside the task, we can use the time variables. Means for suppose at the rate of negate clock or #20, like this cannot be used inside a function, but they can be used inside a task. So with this particular major difference, these functions will be majorly used inside the RTL, inside the code, but these tasks are majorly used inside the test bench code. So the second major difference is if we cannot use any timing things related in the function, this function can be synthesizable. But that is the reason why we are also preferring them inside the design. But if we are using any timing, we can or cannot use the timing inside the task. If we use any timing inside the task, it is not synthesizable. So the functions can be simulated within the 0 time. And in the tasks, if we are giving any delay, according to the particular delay or according to the negate or the passage of the clocks which we are giving, it will be running. So the major difference later lies between what is the syntax. So what the syntax for the function would be the function, the name of the function, and we are also going to consider the lifetime of the function that I'm going to discuss at the end of this one. So the name of the function, and after the name of the function, whatever the input variables, whatever we require, and finally the end function. So here we can define the syntax can be defined something like task, the name of the task. If there are any inputs, we can define the inputs, and if there are any outputs, we can define the outputs, and later we can use the end task. So whenever we are just considering the difference between the functions and the tasks, both may seem to be very simple or same for us, but the major difference lies between whatever the inputs which we are giving and whatever the outputs which we are retrieving. See, inside the function, we can give n number of, at least one input has to be given inside the function, but in the task there is no necessity for taking at least a one input. And inside the function, you can you can also use any return values, but here you can't use any return values. Here you can use this particular name of the function as only a return variable, and you can also return the type. For suppose if we require any integer value, we can also send back the, for suppose if we require an integer value, we can also return an integer value. So in the task, we cannot return anything. So there lies the major difference between the task and the function. So majorly, with the one more thing to remember, the common point between both of them is inside the function and the task, we can only define the variables which are of which are of a reg variable or integer variable, nothing but which are of the procedural type. We cannot define any wire type or net. Wires or nets you cannot declare inside the function or inside the task. So one more major difference between the functions and the tasks which lies is in the operation. So for suppose let us consider there is a block. Let us consider there is a block and there are two inputs and we require the sum. Let us consider this is a function. So what I'm going to do from my DUT, every time I need to send two different variables and this function should send the sum value. For this particular operation, we can only use the functions. The task cannot be used. Why? Because we have only considered that tasks cannot return a value. So that is the major difference between the function and the tasks. And also due to the synthesizable point of view, we majorly prefer functions inside the DUTs or the RTL code and the tasks inside the test bench code. This is the major difference between the functions and the tasks. And if we are declaring some variables inside it, there is a necessity of using the named blocks. A few compilers will be retrieving an error if we are declaring some variables. For suppose here I wanted to declare an integer I. A few compilers are giving an error message stating you cannot use the functions inside the unnamed blocks. So that is the reason why we take the help from the system Verilog and we are going to use the named blocks. The named blocks will be something like we will be using the begin and we will be using the end, and at the begin and at the end we will be naming with the same variable, the same name or something, some variable. So with the help of that we can also declare a couple of variables inside the functions and the tasks. But the only major difference will lies in, and also one more difference is you cannot give any output variables here. You cannot give any output variables inside the function. But inside the task, you can also give the outputs as well as the inputs. That will be the major point of the difference. So this is the difference between the task and the function. But whenever if we are using the function, we can use that as an in both the combinational procedures and as well as in the sequential procedures. But at the tasks, we are only going to use them inside the sequential procedures. We cannot use them. For suppose if I want to take a value of the assign statement, I can use that with the help of the function. I cannot use that with reference with the task. So that is the major difference. But the major disadvantages of the tasks and the functions are, see, let us consider there is a program code in the function where I am sending the first two inputs initially, and let me consider this is the adder and I'm sending the 4 and the 5 values. So the sum of the 4 and the 5 should be 9. Let us consider in the meantime, I have also sent two different more values. So I have also sent the 6 and as well as the 4. So what should happen? For these two particular values, I should get the value of 9. And for these two particular values, I should get the value of 10. But that will not happen inside the functions and the task which we have declared, because we have declared everything to be as a static one. So what will happen? It will not take the earlier values. It will take the latest values only, and it will return the value 10 for both the cases. So this is one of the major problems. So to overcome this problem, we just need to define the lifetime of the function or the task. Defining the lifetime of the function or the task is by using the variable called as automatic. Automatic. So how can we use this particular automatic is, let me consider the function. Let me consider the variable automatic, the name of the function, and everything will go on. So whenever we are using the automatic, what it will happen is on each call, a new particular memory will be invoked. A part of this function is being created, and in that particular function, something like a part of the function will be created like this. The 4 and the 5 will be given, and we are going to get the value as the 9. And the second part, as we have called this particular function for the second time, what it will happen? It will create the 6, it will take the values inputs like 6 and 4, and the value of 10 will be, we will get the value of the 10. So by using the automatic, we can just save this particular thing. But one problem is, if at all we are using the automatic, we cannot access any internal variables of the function. On every invocation, a new memory will be created. So this is the advantage of the automatic task. So this is the difference between the functions and the tasks with reference with the Verilog. So the next one would be the difference between the intra-assignment delay and the inter-assignment delay. So the intra-assignment delay and the inter-assignment delay, they may seem to be very similar. So what does it mean by the intra and the inter? So the intra is nothing but, let me consider, first the delay is being applied, the delay is being applied, and here this is nothing but A plus, sorry, A plus C. Okay. So the major difference, whatever we have understood from the blocking assignment is what should happen. Whatever the LHS value is there, this particular LHS value in the blocking assignment should be first evaluated. Later, it has to be assigned to the value of the B first, means whatever the value on the LHS side, it should be assigned. The RHS should be assigned to the LHS, and in the LHS side, means after the execution of this statement only, it should come to the next statement. But whenever we are using some particular delays, a strange thing would be appearing here. So whatever the strange thing here which would appear is, whenever we are using hash by here, what will happen is, what on this particular side. So first what it should happen, it should first update the values whatever the which are there on the LHS side. So here what it will happen, first whatever the values of A and C are there, those values will get updated, and all those values will be getting assigned to the variable B after the 5 nanoseconds, after this particular delay. Here what would happen, this statement itself will start at after the 5 nanoseconds. The statement will be waiting till the 5 nanoseconds, and after the 5 nanoseconds, whatever the values of the A and C are there, those two values will be considered and the sum will be computed. They will be assigned to the value of the B, and later it will go to the next statement. This is the major difference between the intra and the inter. We are majorly in the test benches, we are majorly preferring this particular part, and instead of this particular hash 5, we are also trying to prefer in a few, whenever we are applying the resets for the reset signals for the D flip-flops and all, we are trying to use at the rate of neg edge clock or the pos edge clock signals. So basically this one will be preferred. So this is the difference between the intra and the inter-assignment delays. So next comes the $display, $strobe, $monitor, and $write. So in order to understand these particular things, we need to first understand what is the stratified event queue. As we have discussed earlier, what is the stratified event queue? This will be the active region. So after the active region, it will be the inactive region. So after the inactive region, it will be the non-blocking assignment region. And after the non-blocking assignment region, it will be the monitor region. And after this monitor region, it will go for the next time slot. So it comes from the earlier time slot, it goes for the next time slot. So here there are 4 things. The first thing, which is the $monitor. Sorry, let me consider the $display first. So what does it mean by the $display is, whenever this $display is being called, this particular $display will work in the active region. So for suppose if you are using the blocking assignments, non-blocking assignments, and if we are calling the $display statements, whatever the value after the once whatever the earlier value of the our LHS variable is there, that value will only be displayed. The updated value will never be displayed, because in the active region only LHS of the only RHS of the non-blocking assignments will be computed. Now let's come to the $monitor. $monitor. So what does it mean by the $monitor is whatever the variables inside the $monitor except the time. For suppose if we want to declare the $monitor, we are going to take something like a percentage 0t, which represents the time scale. And after that, we are going to take some variables like a equals to percentage d, b equals to percentage d. Some variables we are going to take, except the time, whatever whenever there is a change in this particular values of a and b, so those values will get printed, but the change is being evaluated after the non-blocking assignment region. So nothing but the non-blocking assignment region is almost in the monitor region, but what will happen is it will be a continuous monitor. So for suppose there are almost 5-6 variables which are varying at every frequent thing, all those variables, all the changes will be monitored and they will be printed in the simulation results. So that is the $monitor. And similar to the $monitor, I will be having the $strobe. So what does it mean by the $strobe is whatever the values which are at the end of the simulation, it is going to print in the $strobe. But the difference, it is almost similar to the $monitor. But the major difference between the $monitor and the $strobe is the $monitor is monitoring continuously, but $strobe will only print for one cycle and it will close. It will not work again. So that is the major difference between the monitor and the strobe. So similar to the $display, we will be having the $write command. So this will be also evaluated in the active region only. But the major difference between the $display and the $write command is in the $display, whenever we are trying to print something, after that particular $display statement, the cursor automatically moves to the next line. But in the $write, that will not happen. Immediately after that particular variable only, whatever the variable which has been printed. For suppose, let me consider the two things are to be printed, variable 1 and variable 2. Whenever we are using the $display statement, it will display in the similar fashion. But the $write will not display something like this. It will display something like variable 1 and variable 2. So everything will be inside a same line. And if we want to move to the next line, we need to use the /n inside this $write. But this /n will be already inbuilt inside the $display. That is the major difference between the $display, $write, $monitor, and the $strobe. So basically, in all our programs, we will be preferring the $monitor. But if at all, at one particular point, we are having a couple of error in the program and we want to identify what is that error, we will be using the $display statements wherever we are thinking of this part is an error. So this $write and all, they will be mostly used whenever we are writing some particular file information into the file, but that with a different command called as $fwrite. So this is with reference with the $display, $write, $monitor, and $strobe. So the next one is what is difference between the wire and the register. So before discussing this, the first thing which we need to discuss is wire and the register. So the major difference first we means by seeing these two things which we can understand is in a simple terms, we can use only the assign statements should be having the wire, and whatever the things where we are going to use inside the initial and the always blocks should be the register. So the major meaning for this is whatever the continuous assignment will be considered, we will be considering them as the wires, and the registers are nothing but the procedural assignments. The meaning register doesn't mean that it is a register or it can store some value. It's just called as a reg variable. So the wire is nothing but it cannot store anything. So it will be just like a straight line, whatever the thing which is being given as an input here, the same thing we are going to use in the reg variable. And one more major going to consider that particular wire initial value as is the but in the wire. So Z is nothing but the high impedance variable, and the reg is nothing but the X, which is represented with the don't care. So what does it mean by the don't care is we can also consider the don't care as the clash between the drivers. For suppose, let me consider there is a value 1 here and there is a value 0 here, and both are connected. So there will be a clash between the variables. So the initial value will be a don't care. Here the initial value will be a Z here. And also one more thing, whenever we are using, so here we can use them inside the initial and always blocks. And inside this initial and the always blocks, the wire cannot be used. And within the assign statements, the reg variable cannot be used. So helpful for us in the complete procedures. So this is the major difference between the wire and the reg variables. And one more thing. So the wire is nothing but the continuous assignment. There is not only a wire, there are more number of things. So the equivalent to the register variables is nothing but the integer. The most popular thing which we are going to use are nothing but the integers. Here we are going to consider the tri-reg variables, wire or tri. So here we will be also having the W and WR and everything, but the mostly we will be preferring the tri and the wire. And here the most popular thing is nothing but the integer. Instead of the reg, we can also comma or with the or operator. The second one would be nothing but using of the star, and the third one would be nothing but everything which is synchronized with respect to the clock, something like pause edge clock. So the meaning of this is as similar to whatever which we have thought earlier. Always, the always blocks is the name itself is telling that always. So whenever there is a trigger happens, means if there is a change of the value in the A, B or C or whatever the variables which we have taken inside the sensitivity list, then immediately this block would trigger. So that is the meaning of always at the rate of A, B, C. And whenever this block would trigger, whatever the statements which we have given inside this particular block will be executed in the procedural fashion, as these are the procedural things. But whenever I'm using the star, for suppose let me consider a marks, and I'm having 3 input variables, A, B, select. For suppose which we have in the sensitivity list, if you have forgotten the value, taking the value of the select, whatever the value will be there, everything will be wrong. So whenever there is a chance of forgetting a few values in the combinational thing, then we are going to use this particular star. But the major disadvantage of this star is we can't use any memory related things. If we want to design a memory, we can't use a star. And the next one is nothing but the at the rate of pause edge clock. So pause edge clock or the neg edge clock is nothing but whenever there is a variation in the pause edge or the neg edge of the clock, and depending upon the usage of this particular keyword, this particular always block will be triggered. But the thing which we need to remember is whenever there is an update in the sensitivity list, or whenever the variables inside the sensitivity list changes, then immediately the always block will trigger and immediately the statements inside that will be executed. But that is not the blocks. And what does it mean by the initial blocks is the syntax will be something like initial, begin, and end. So whatever the statements which are there inside the initial, begin and the end blocks, they will be executed only once. That is whenever we have called them, only at that particular time they will be executed. So this is the difference between the always and the initial blocks. So basically the always blocks are always used inside the RTL code while writing the RTL code. And the initial, begin and the end values are really helpful whenever we are writing the test bench and we want to assign the values to the duty. Then this particular initial blocks will be, whenever there are multiple always blocks or multiple initial blocks, we don't know which block will be running at what particular time. There will be, even though they need to run parallelly, there will be a very small delta time between the running of those two particular blocks. So that is the reason why we have to be very cautious in assigning when using the variables. That is the reason why we need to prefer always the non-blocking assignments for both the cases whenever we are using whenever we are trying to use both the cases. So this is the major difference between the the initial and the always blocks. So how many flip-flops are needed for the following codes to be synthesized? So basically, let us just consider this code. The same example we have just seen in the earlier thing while discussing the blocking and the non-blocking assignments. So here initially it was just given that always at the pause edge of the clock, the value of the B is assigned to A, and the value of B is assigned to C. A is assigned to B and B is assigned to C. As it is a blocking assignment, first what it will happen, the synthesis tool, what does it does is, instead of B, after the end of the statement, it will store the value of A. So here what happens, whatever the value of the B is there, the A will be assigned. So what will happen, the value of the C will be A now. So obviously for this, only one flip-flop is required. So this is nothing but the clock, this is nothing but the A, and the output is nothing but the C. But if at all I'm considering the non-blocking assignments, E is B. So as we have already discussed, whenever we are using the non-blocking assignments, irrespective of the statement order, this synthesis tool is going to consider one flip-flop. Means if we are using at the rate of a postage clock or any variable, it is going to consider one flip-flop for one particular statement. So what will the synthesis tool does is, so first it will consider this input to be the A, and it will assign the values to the B. So this will be the clock signal. And in the next cycle, what it will happen, whatever the value of the B is there, that particular value of the B is being assigned, means the output will be assigned to the C. So here what it will happen, there are two statements and it takes two clock cycles for the value to get updated. In the first clock cycle, the B value is updated, and as the B value is the earlier B value is not updated, the value of the C will be the don't care only, as these are the reg variables. And in the second clock cycle, whatever the value of the B is there, that will be assigned to the C. So that is how for this one flip-flop is needed, and for this two flip-flops are needed. So later, what is the difference between the equality and the case equality? So first of all, let us just consider a small example which can really figure out what is the difference between the equality and the case equality. Let me consider A is a 4-bit variable. Let me consider, as we will be using in the initial blocks, let that be a register variable. So let me consider A is nothing but 4-tick B 101x. And let the value of the B is 4-tick B 101x only. Let us consider. So here also I'm considering both the same values, A to be 40101x and B to be 4-tick B 101x. So initially what should happen whenever I'm considering the value, means what does it mean by the equals to? Double equals to, it's nothing but the equality operator, nothing but I should compare the LHS value with the RHS value, and if both the variables are one and the same, it should give me the output 0, and if both the variables are not one and the same, then it should give me the value of 0. So here what is happening, 101x should be equals to 101x. So obviously by seeing this, we should consider that the output should be 1. But no, the output will be 0 here. Why it is 0 is, this value will be a don't care. Why it will be a don't care is, this particular is equals to operator cannot compare the Sir, excuse me. Yes. So this it will reflect an value of a don't care, because it cannot compare the don't care or the z values. So as it cannot compare, it gives us I was not enabled to compare. So to overcome this problem, we will go with the case equality. So what does it mean by the case equality is, if I'm using the case equality, obviously it will be comparing the bit by bit, and whenever the bit by bit are one and the same, obviously it will it will give the value of the one. And if these variables are not same, if A and B are not same, then it will give the value of 0. So obviously, so here we can just consider that here we can just consider what is the major difference between the case equality and the between the equality operator and the case equality operator. So based upon our application in the test bench, we will be using the case equalities and we will be using the equality and in the case equalities, and we can also use them inside. Excuse me, sir. There's a lots of disturbance, if you don't mind. There's a lots of disturbance. Please don't mind. Yes. So that is the major difference between the equality and the case equality of that. So the next question is, what is given the following Verilog code, what is the value of the A which is displayed? So first let's look at the code. So inside the code, what is happening here? The first is nothing but the blocking assignments, and the second is nothing but the non-blocking assignments. So let's consider the stratified event queue. So whenever we are considering the stratified event queue, what we would just consider, the first will be the active, inactive, non-blocking assignment region, and finally the monitor region. So here, whenever the blocking is occurred, it should occur inside the active region. So we also know that a non-blocking value of 1 will be assigned in the non-blocking assignment region, and the $display will be assigned in the active region only. So now this value will be updated in the NBA region. These both will be updated inside the active region. So from this only we can just tell that obviously whenever as the $display is in the active region, whatever the value of the A, and also whatever the $display statements are there, that thing is taken care by the active region. Whatever the $write statements are there, those will also be taken care by the active region. And in the inactive region, we are going to just consider whatever the #0 statements are there. If at all, if we are giving any #0 assignment before the statement, then that type of statements will be executed inside the inactive region. But this is one of the cautious region which to operate. So if we don't operate it perfectly, there is a chance that the circuit, whatever the values which we are giving inside the circuit, they may lead to a don't care. And this will be nothing but the non-blocking assignment region. So as we have already discussed, whatever the LHS of the non-blocking values, non-blocking assignment will be taken care by the non-blocking assignment. And the monitor, as usual, it will use the $monitor and the $strobe values. And after this, it will go for the next time slot. So this will be a single time slot, and this will be moving to this will be the earlier time slot. This will be the next time slot. So this is the major difference between the Verilog event queue or Verilog event scheduler. So here we are having only 4 things, but in the system Verilog that has been updated with 21 different blocks. So this is the Verilog event queue. So the next one would be, what is the difference between the begin and end and the fork and the join? So there is only one difference. So let me consider the begin and the end. Let me consider 2 statements. For suppose at #10, I want my value to be A to be 1, and after #15, I want my value of b to be 2. Let me consider just a rough code. So as it is a 2, it requires at least 2 bits. The single bit register is not sufficient. Let me just take a piece of a code. So here what it will happen, first, whenever the begin statement is started, whenever in between the begin and the end, what it would happen is, first when the execution starts at the begin, after the 10 nanoseconds, the value of A is assigned with 1. So once the value of A is assigned with 1, and after this, at the 15 nanoseconds, the value of B is the fork and the join. And let me consider the same statements. Hash 10, A equals to 1, and hash 15, B equals to 2. So if we are considering this, what it will happen is the fork and the join is nothing but whatever the things which are there inside the fork and the join will be running concurrently. So that means it will start at the 0 time and it will also start at the 0 time. So at the 10 nanoseconds, the value of the A will be 1, and at the at the end of the 15 nanoseconds, the value of the B will be 2. Here, if you can just observe, at 25 nanoseconds, we are getting the value of the B to be updated, 10 plus 15. But here, if you can just observe, at 15 nanoseconds only, the value of the B is getting updated. So based upon our requirements, we will be using the fork and the join. So, there is one more thing, like Verilog is a concurrent statement, concurrent language. Inside the concurrent language, for a few statements to execute procedurally, we are using again the procedural blocks. And inside the procedural blocks, if there is a chance that we want everything to be executing concurrently, then we can use the fork and the join blocks. So this is the fork and the join. So majorly this fork and the join blocks are majorly used inside in a few cases where, for suppose 4 conditions are there, and if any one of the if all the conditions are executed, then only it needs to come, and all the executions should start parallelly. At that particular point of the time only, we will be using the fork and the join. So what is difference between the case, case-X and the case-Z? So this can be explained with a very simpler example. So let me consider the case X and the case-Z. So with this particular thing only, we have got the meaning of the case equality and case inequality, which we have observed earlier. So first, let me consider the case. So for suppose inside the case, if you have given a variable, and if you want that particular variable to be assigned, means for suppose there is a variable A, and the value of the A, when the value of the A is 1 only, it needs to continue. Then obviously what it will do, it will search for the 1, and immediately it will go for the, means it will execute whatever the commands which are there beside the 1. But for suppose, let me consider there is a don't care value or a Z value. Then what will this one do? As this is an equality one, case equality one, it cannot get equated to any of the things. So it will directly go to the default statement. It will directly go to the default state. So then that is a major means. So it is not in a position to detect either the X or the Z values. But whenever we are considering the case Z, let us consider the Z comma question mark. For suppose if there is a value something like, it should be something like 1 question mark Z. So nothing but I want only my LHS to be 1. So the last MSB to be 1. So then I can just give like this. Means it will not consider the Z, and it will not consider the X, and it will only compare the remaining variables. But here it cannot detect the X. So if at all some value with the X comes, it again goes to a default variable. So this is nothing but the case X. All the X, Z, and the question mark are treated as a don't care only. So whenever the X, Z, or question mark comes, that particular variable, it is not going to compare. It will be comparing the remaining variables. But the synthesis of the case X, the case Z, always remains one and the same with a very small minute pieces, because the synthesis tool cannot detect the high impedance values. The for a few things the synthesis will be different, but or else everything will be one and the same. So this is the difference between the K6 and the Kc equalities. Now K6, Kz and the Kz. So now the next thing is, what is difference between the synchronous FIFO and the asynchronous FIFO? So what does it mean by the synchronous FIFO is, see, let me consider what is the functionality of a FIFO first. So let me consider this is a FIFO. I need to push some variables and I need to pop some variables. So for pushing, let me consider I need to write them. And for popping, I need to consider I need to read them. Okay. So if for writing and reading, there is a single clock, means the FIFO is working with reference with a single clock, that FIFO we are going to call that one as a synchronous FIFO, because everything is synchronized to a single clock. But the asynchronous FIFO is nothing but if there are different clocks for the write and the read signals. So then what will happen? Whenever the read clock is enabled, then only it should read, and whenever the write clock is enabled, then only it should write. So this particular thing is nothing but the asynchronous FIFO. So this is one of the major applications in the Verilog. So the asynchronous FIFO. So here we can just observe that it is a synchronous FIFO, as the clock is one and the same. If we are changing the clock for the read and the write enabled signals, then it would be an asynchronous FIFO. So what is difference between $stop and $finish? So for suppose in our program, there is a we need to understand the execution. For suppose there is something which is getting executed, for every 100 nanoseconds, the values are getting changed. Let us consider for every 100 nanoseconds, the values are getting changed. I want to observe, even though if I'm using $monitor or even though I'm using $display, I may not get the required variables, because the next part of the execution is also continued, and the $display or in the $monitor will display the values based upon the complete flow of the execution. But what I want is, I want to check the values at every step. Wherever I want to check the values, then I'm going to use this $stop. Whenever I'm going to use this $stop, what the tool will does is, it will stop the execution at that particular point. It will not completely exit from it. It will just stop the execution temporarily. And whenever again we are giving a command in a few tools, we will be using the command run again, and again it will be running, or it will resume. So it will stop and it will resume. So that is the $stop. But when it comes to the $finish, whenever we are giving $finish, irrespective of the position of the program, after that particular time, the program will get completely executed. Means it will be completely closed. The execution will be terminated and it will come out of the particular tool. So if we need to use it again it needs to be invoked. So that is a major difference. So the usage of the $stop, it will be inside the synthesis tool only, and we can proceed for the next step. And usage of the $finish, it will completely exit from the program after the specified time delays or anything. So that is the difference between the $stop and the $finish. And finally, generating a random number in Verilog. So basically, how to generate a random number in Verilog? The basic idea behind that one is, we need to use $random. So basically, $random may produce an erroneous results. Nothing but based upon whatever the value which we have taken, either it's an integer or anything, it can produce any erroneous values, and it can be either signed or unsigned, anything. So for suppose if I want that particular values between a particular range, so this $values will generate random values. Now, if I want a range, means if I want the values to be from -10 to +10, or -20, -100 to +100. I'm just going to use the percentage symbol and I'm just going to use 100. So this statement will tell the tool that you need to generate the random values between -100 to +100. But let us consider I want the values only between 0 to 100. So if I want the values between 0 to 100, what I'm going to do, I'm just going to consider a flower bracket. There are two options for us. One is considering the flower bracket, and the second one is using unsigned. But usage of flower brackets will be an advantageous one because it's very simpler when compared. Means it's not an advantage, I can't tell it, but it's a simpler task when compared. So this one will produce the random values between 0 to 100. So this is the random. Now, for suppose if for a range, if we require some particular values or variables in between that particular range, then we are going to use something like means here instead of this particular thing, let me consider I want the values between 3 to 10. So the minimum value here is 3. So the minimum value here is 3. So as the minimum value is 3 here, so what I'm going to do, I'm going to use the 3 here, 3 plus, because the minimum value is 3. And here, what should be the difference? It should be, it should be the max value minus min value. So what it will do, 3 plus whatever the value between the max and the min is nothing but the percentage 7. And also we want only the values between 0 to 7 because as we are using the flower brackets here. So it will randomly generate the values between 0 to 7, and that is the reason it can print the values between 3 to 10 here. So this problem has been overcome in the system Verilog by using $u random range. $u random underscore range. We can directly specify the range. So this is the generating the random values. So and finally the up down counter. So what does it mean by the up counter and the down counter? So first let's discuss what should be a black box like. The black box is nothing but the overall view. Obviously there should be a clock signal, and there should be a chance for me to load the signal. So means I need to load, for suppose let me consider it's a 4-bit or 4-bit counter. 4-bit counter. So obviously there should be a data in value. A data in value which should be of a 4 bits, and there should be a data out value which should be of an 4 bits. Means what should be the ultimate value of the count or anything. So and whenever I'm giving the value of a load, so whatever the value which I'm giving here, it should consider. If I'm not giving anything, it can start from the 0. So load, and now as it's an up down counter, the other two inputs should be the up as well as the down. Either we can take it like this, or we can take a single input like up bar, down bar. So nothing but when the value of the 1 is high, then it will be the up counter. And whenever this particular variable is 0, then it will be a down counter. So there are two options which we can use. So now let us consider the truth table first, basically. So let me consider the up counter. So everything will be in synchronous with reference with the clock. So there is a clock here, there is an up counter here, and there is a down count. There is an count value here. So for suppose there is a clock and the up is 1, obviously as the initial value we will be setting it, and also there should be a reset C. So initially when the reset is 1 and when the up is high, obviously it should increment until this particular up value should become 0. And whenever the down value is 1 and the up value is 0, obviously it should down count it. So the same thing has been explained here with reference with the passage of the clock, and based upon the control signal, we are either going for a up counter or a down counter. So yes, thank you. And if you are having any questions, you can just ask. Sorry, I haven't seen this. You have asked it somewhere at 10 minutes before. I haven't seen this. From next time, I'm going to change the color. So till now, if you are having any doubts, you can please ask. If because of the change of the color, if you are unable to understand something, you can ask. Yes? Anyone? Please? Any questions? So I think we have discussed almost 6 to 7 topics. Even though there are more number of questions, the topics only cover 6 to 7. So the non-blocking and the blocking assignments. The first thing was nothing but the non-blocking and the blocking assignments, NBA, blocking assignments. The second thing is nothing but the difference between the task and the functions. The third thing is nothing but, and inside the task and the functions, we have also discussed what does it mean by the automatic. In the Verilog, this automatic usage will be a really advantageous one for us. So later we must have discussed what are the different types of the delay, the intra-assignment delay and the inter-assignment delay. And in the next one, coding. So which code do you require? The up counter and the down counter ones. Please, which code do you require? The up counter and the down counter one. Verilog coding. So just tell me an application. We will discuss the code for it, not a problem. Means for what thing you require the code, the syntax or anything. For an adder, for an half adder, for an full adder, triple carry adder, or for an D flip flop. Yes, please. You are a beginner. Okay, fine. So I was very sorry for it. I was just instructed in this fashion to discuss the questions. So, uh, yes, I'm unable to understand. Please. Please, I'm unable to understand. Could you please just drop the message in the box? So, means for discussing the Verilog coding from the starting, we require a couple of things. But let me just be very precise enough for you. So let me consider there is an half adder and there are two inputs, A and B, and there are two outputs, sum and carry. So here, if you can just observe, there is no dependency. Means there is no dependency of a clock or anything. So
like panels Intel कोई तो in the typical.
yes.
तो वो इतने डिवाइस ले सकते हैं और ऑफलाइन टूल को ले हमारी वाली वर्किंग एप्लीकेशन पढ़ाते हैं ना पढ़ाने वाले इसलिए हमारा कोई ऑफलाइन नहीं बड़ा सकता ऑनलाइन भी लेता क्योंकि ऑफलाइन
Sir, please, I'm getting lots of sound. If you're talking with me, please. So, in order to write this particular Verilog code, the syntax would be the module and the end module. The module and the end module. And here it would be the name of the module. And inside the name of the module, we will be having the sensitivity list. So for suppose, let me consider I have taken S, C, A, and B. And every statement inside the Verilog, except the end module and a few specified statements, except them, everything should be followed by a semicolon. So for suppose, let us consider there are two inputs. I'm going to use them something like input A, comma B. And here the output, I'm just going to consider this one as S, comma C. So I have defined the inputs and I have defined the outputs. Here I haven't used anything. means either it's a wire or a ridge. I haven't used anything. So that's the reason why we are implicitly we are going to consider this one as a wire. Implicit is nothing but without any definition on the default. We are going to consider, guys, please. I'm getting more noise, please. Yeah. So here implicitly we are just going to consider this one as the wire. So as these are wires, we have already seen that we need to use the assign statements. As we need to use the assign statements, I'm just going to consider this one as assign yes. So what will be the sum here? We already know that it's nothing but AX or B. And what will be the carry here? The carry is nothing but A and B. Okay. So this is the basic syntax. So this one we are going to call this one as the sensitivity list. This one is complete. This is defined as the sensitivity list. This is the name of the module, and the major syntax is the module and the end module. And for assigning the values from input to the output, we are using the assign statements, which is nothing but the continuous assignment. So this is a basic code. So to discuss it in detail, we require more number of hours. In a very short span of 40 minutes or 1 hour, it's very tough. We require more than 30 to 35 hours for the Verilog completion. So till here, if you are okay, please let me know. If you are having any doubts, let's discuss. Still, there is 2 minutes of the meeting time, I guess.
Yeah. Anyone have any doubt, any query? Anyone have any doubt, any query? Okay, so should we end the meeting? So the rest we can discuss in the next sessions, right?
Yeah.
Yeah, we can do other meetings on the next day, right? Today it is sufficient for the
okay.
Yeah.
Okay. No problem. Means in the next meetings, means if you are telling that they are very new to the Verilog, if we can start from the starting, it could be helpful rather than discussing.
We will discuss. I will discuss with them and tell.
Yeah. Okay.
Okay.
Thank you.
Thank you so
Thanks
much.
everyone. Thank you for the patience.
Thank you.